In this class we are going to discuss about the next concept, that is interface circuits. Okay, so now we'll see here how the interface will be there between different computers. Okay, so now we'll see here how the interface will be done in between computers. Now we'll see here. So generally we know that if you are saying one computer is communicating with other computer, compulsory in between one mediator will be there, right? It should be in between these two computers. There should be a computer. There should be a one mediator is present, right? So that means compulsory, if one computer is communicate with other computer, means we have one mediator will be there in between that. We need one mediator for communicating two computers. Okay, so just imagine this is a one computer and this is a one computer here. Okay, so that mediator is nothing but we can represent it as bandwidth. Okay, so mediator is nothing but the bandwidth through the bandwidth. That means the first computer of the bandwidth, and that is communicating with the next computer of the bandwidth. In that case only the data will be passed from one computer to the other computer. Okay, so the point here that we need to see how the connection will be done at the sender side, and that means at the sender side means here the computer is connected, and at the receiver side how the computer is connected. Okay, so see here you are imagine, so this is the sender part and this is the receiver part. So this sender having one computer and receiver having one computer. So now we need to see here how the data will be transmitted from sender to receiver. Okay, so those computers are connected with the help of the interface circuits. So what is meant by interface actually? The interface. Okay, interface, this word will be used when we are talking about a mediator in between two systems. Okay, so for example, let us say this is a sender and this is a receiver. Okay, so here we are having sender and here we are having receiver. Sometimes sender wants to send the data to receiver part, right? Like that. Sometimes a receiver wants to send the data to sender part, right? That already we knows that information, right? So we know that there will be some communication media in between these two systems. That means in between these two sender and receiver part. Okay, so for that this systems having, that means this sender having some bandwidth in between, that means sender having some bandwidth and receiver having some bandwidth. So there will be some bandwidth between the sender and receiver. But how this communication media is connected at the sender and how this communication media is connected at the receiver. Okay, we need to know this point. So we call this connection interface is interface circuits. Okay, so the purpose of these interface circuits are to establish the endpoints. Okay, it establishes the endpoints connectivity. How the sender will be connected and how the receiver will be connected means for that purpose it will be establishing the endpoints. Okay, so how we are going to find out this means with the help of endpoints connectivity. We call those endpoints, that means we can find out that connectivity. Okay, so with the help of endpoints connectivity we can find out that interface circuits. And in that there are two ways in which it can connect the interfaces at the sender part and receiver part. Okay, so two ways we are having for this endpoints connectivity. So that is nothing but the first method is with the help of parallel ports. Okay, and the second method is serial ports. So I already mentioned here. So parallel port and serial port. So the end-to-end communication between the various systems can be done with the help of either parallel port or with the help of serial port. So now we will see what is parallel ports and what is serial ports. Okay, so first we will go with the parallel port. Okay, so generally parallel ports are nothing but the advantage of parallel port is from one system to okay. So what is the advantage from parallel port means uh, the best advantages from the parallel port is from one system to other system. Okay, we can transmit the data simultaneously. That means parallelly we can send the data at a time. Okay, na? So more number of bits will be transmitted at a time. That is the best advantage from the parallel ports. Okay, so for example, this is a one computer or one system, and this is a second system, and like that here I have one more system, third system, like that. So from one computer to other computer, the transfer of data can be done simultaneously by using more number of bits at a time. Okay, we can transmit at a time more number of bits, which means one computer to other computer which are making use of a parallel ports, they can transfer the data many bits at a time, and the transfer of data can take place simultaneously. Okay, so now if the transfer of data many bits at a time, and if the transfer of data can take place simultaneously, you know automatically will be the third advantage is fast transmission. You can observe here many bits at a time we can transfer. Okay, first advantage is many bits transmitted at a time. That means at single attempt we can transmit the many bits. That is the first advantage. And second advantage is these are many bits will be transferred simultaneously. Right? So by using these two advantages we can get the third advantage, that is fast transmission will takes place. Okay, the transmission of data can takes place very fast. So there are the advantages of the computer which are making use of the parallel ports as interface. Okay, so see here, this is the parallel port diagram we are having. So one side of the interface we are having here the bus signals. These are the bus signals we are having one side, and the other side of the interface will be connected to the data path. This is the data path and this is the bus signals we are having. Okay, so here we have a keyboard. Okay, keyboard and switches. Okay, so whenever we press the key on the keyboard, that will be converted into the codes. Okay, so whenever we are enter the some information with the help of keyboard means automatically that will be converted into the codes. That codes we can represent it as here ASCII codes. Okay, so that is called as data. Okay, so thus ASCII code ASCII characters with the help of encoder and debouncing circuits. Okay, keyboard will be entered some information, so that will be represented as ASCII codes with the help of this circuit, encoder and debouncing circuit. So now the data will be given to the next block. Okay, see here we have the input path and output path. So here input path is nothing but keyboard, and from this keyboard the data will be transmitted to processor part. Already I explained this basic information from the first unit of last concept, that is basic IO operations. The same concept is repeated here. Okay, so go and check that concept. Okay, so see here when I press the information, that will be given to the encoder box. Okay, so with the help of this encoder box, directly that information will be converted into the ASCII codes. Okay, so now this information ASCII codes will be our input data, right? So that data will be given to the input interface. So this input interface consists of the data input as well as it is having some SIN, that means flag flag bit will be there, right? So whenever the information will be comes from the keyboard, so that information will be stored in particular register, that is input data register, data input. Here the information will be stored. So whenever the information it consists, okay, so that means once the data input register consists some information, automatically the SIN flag, so without it consists of any information means SIN flag will be 0 at initially without it consists information. Okay, so whenever it consists information, data input having some information, no, at that time the SIN flag, status input flag, automatically changes to 1. 0 can changes to 1 because it consists of some information. Okay, so that means when a key is pressed, whatever the data we received at that time, the valid signal can changes 0 to 1, because the ASCII code to be loaded into the data input and SIN will be sent to the set to 1. Okay, so after that this data input register, whatever it consists the information, that will be transferred to the processor block with the help of bus signals. These are the bus signals we are having. This is the data bus, it carries the data only. Address bus, if it is consist address, that address will be transmitted. And this is the read and write, so for reading operation and for writing operation, that is a one more bus signal. Master ready and slave ready, these are the control signals, okay, controlling the operation. Okay, so now the data input will be whatever it consists the information, that will be transmitted to the processor block. Okay, so when the processor reads the content of the data input register, then automatically SIN flag will be changes to 1 to 0, because the data input is consists the information that will be transmitted to processor, no. So whenever it transmitted the information, automatically this will be empty. Empty means 1 can changes to 0. Okay, so now with the help of this address only, the processor can identify from where the data will be there. Okay, so with the help of this address line, so now the processor will identify the where the information, wherever data will be present, so that will be find out. Okay, so this is the parallel port interface circuit. Now coming to the serial interface. Okay, that is the second part we are having, serial interface or serial port. So this is a simple topic as compared to parallel interface. So serial port is nothing but here, when we are talking about serial ports, in that if you take the similar diagram, okay, if you take the similar diagram, the only the difference is one way transmission will be takes, which means transfer of data can takes place in only one way, not simultaneously. Okay, it's single time it will be send the data, not multiple transmission here, not many more number of bits transmit at a time here. Okay, only single bit one way transmission will be takes place here. If this computer sends the data to this another computer, okay, so the computer sends the data to this computer and this computer again reply back to the data. Okay, so once the computer will be transmit the data, again this computer will be back to the send the data. That means this computer reply back the data here. Okay, so that means sending and resending the data. So two-way communication is possible here. But here if the computer makes use of the serial ports, then they can transfer the data only one bit at a time. That is the first point. And in parallel ports, the transfer of data can takes place at a time. Right? Here the transfer of data can takes place only one bit at a time. In that more number of bits at a time, here one bit at a time. Okay, so that means there is no more number of transmission here. So simply we can say that here the drawback will be there here, that is slow transmission will be there. So this is the drawback will come from the serial interface. Okay, so this is the serial interface, and this is the parallel interface. Okay, here more number of bits at a time, and more all bits are transmitted simultaneously. Because of that we can get the fast transmission. But here only one bit we can transmit, and that only again reply back to the next one. So that means slow transmission will be takes place here. Okay, so this is the concept of interface circuit.